Welcome back, geometry students, to section 2.5 reasoning part 2. This is a continuation of what we were doing with reasoning and starting the proofs. In the first video, you learned about properties of equality and congruence. These are all your moves for proofs. It's not written here, but if you want to see it in the previous section, previous video, go ahead and do that. But these are your moves that help you prove something. Okay, so these are the steps. These are your base, your toolbox, and this will help you get to point A from point B. Okay, so let's get into proofs. That's what we're learning today. Proofs are really the Achilles heel of a lot of geometry students. They don't like proofs, and the main thing is because it's foreign. It's not something that they're accustomed to, but really it's a good way to increase your understanding of not only math, but science and a bunch of other critical thinking processes as well. So let's go ahead and start. What is a proof? So a proof is what we do to get from one point to another. It's a convincing argument. So it's convincing argument using deductive reasoning. Convincing argument using deductive reasoning. Deductive reasoning. Okay, so our argument is we want to say, hey, we're given this information, we want to make a case for this, going from point A, point B, point B, point A, however you want to say it, okay? That's the proof. A two-column proof essentially has the statements on the left, reasons on the right, okay? Reasons are justifications for the statement on the left. So all these things are correlated. This statement right here matches the reason on the right. This statement here matches the reason on the right, okay? So it's a pretty predictable pattern. It's just a good way to organize information. That's a two-column proof right here. If you want to write something down for that, that's great, but just understanding this is the important part. First, you always want to kind of start with your given information. So you're going to write something, and most of the time it's given. It could be given in a diagram. It could be given as just part of a sentence or whatever information it gives, but you have to be given something. You have to have some sort of start, okay? Now, as you build your case, you start here and you work your way down. Each point you make needs to build off the other. So all of this builds until you get to the last statement, which is your proof statement. Okay, this is what you're trying to prove by the end. Okay, so now, and all these, again, these support the statements on the left. So just a recap of that. And this needs to build. You can't go to 4 without having the understanding of 3. The information for 3 needs to support what you do for 4. Now, what does this all mean? Let's put it into practice. This should help. We have to find the value of x in example 1 and justify each step. There's some prerequisite information you need to understand. One of the things that a lot of students don't like about proofs is you need to know definitions of certain words. You need to know postulates. You need to know theorems, postulates. You need to know theorems. And you need to know your moves. So your moves are up here. You need to know these properties too. Okay, and you need to be able to recognize it. And then properties. That's what probably makes it hard, is just being able to recall some of this information. But I'm going to try to assure you that it's really not that bad, especially when you get to the algebra, okay? So here we have some given information. It doesn't list it as given, but we can look at the diagram and see it. We see that we have AOC. AOC looks like it's a straight line, okay? And then we have angle at AOM. It's this one right here. Okay, let me kind of fill it in. I want to fill it in like this. Then we have angle AOC, MOC, and that's that angle right there. Okay. Now, what do we know about these two angles? Well, we know that these two angles need to add up to give us 180 degrees. Okay. Why do we know that? Why do we know that these two things do that? That's what we need to show before we actually find the values of those two. We need to show why we can say that those two angles add together equal 180 degrees. So let's go ahead and get started with our statements. So statement number 1, we are going to say that angle AOM and angle MOC are supplementary. Okay, and we can't just say that without any reasoning. We have to justify why we can say that. Okay, now this is where there's a lot of wiggle room. You could say a lot of different reasons. Okay, there's different forms, and different teachers might accept different ways. For me, as long as you're close and you get to the crux, get to the real kind of the main content of why you can justify that, that's the important thing for me. But if you say there's something along the lines of angles that form a linear pair, now this is one of those words that I was talking about, are supplementary. Okay, let me do some highlighting here. So 1, we see that we have MOC. That's blue. This guy is red. Okay, we have a new word here, supplementary. That's important. We have it over here also. And then the word that I mentioned earlier is linear pair. That's what we talked about when we have two angles adding together to give 180. Okay, so if we have a straight angle, that's a line. If we just cut that into two different angles, that is a line pair. Okay, two angles, two pair, add up to give us a line. Okay, so those are just kind of the definitions you need to understand and have some prerequisite information. This is our first step. So this is step 1. Step 2. Now, we always use the information from step 1 to build. So if we said the word supplementary, guess what? We better expand on that, especially because that's a critical component of this problem. So let's go ahead. We say AOM. What does supplementary mean? Well, we already said it earlier. We know supplementary angles add up to 180 degrees because a straight angle, a straight line, has 180 degrees in it. So plus MOC equals 180. Now we got some math going on. This is much better for us. We're going to be able to make some progress here. Blue, red, okay, equals 180. Why do we know this? Well, this is the definition of supplementary angles. So this is the definition of supplementary angles. Okay, if we say they add up to 180, that's the definition of supplementary. Okay, so that's why we were able to say that. Supplementary means it adds up to 180, and we're good there. Now, we need to look at 2. We're done with 2 to see where we can go for 3. Where can we go from here? Well, we have this and this, but that's not very helpful because there's no values there. There's just essentially a name of two different angles. So we need to somehow put in a value for those two things. Luckily, we have that. We have 2x plus 30, and we have x. Okay, so we are going to relabel this 2x plus 30, and we're going to label this guy x instead of calling it MOC and AOM. Now, why can we do that? Why can we just put in those values for AOM and MOC? Well, this is where we're going to go back to our moves here, and here we see the substitution property. This guy allows us to substitute values in for other areas. So if we know MOC is equal to x, then we can substitute x for MOC. So this is our substitution property. Substitution property. That's our move. That's our move that helps us get from one point, whoops, sorry, didn't mean to do that, one point to another. Here we go, move 4. We got to build off of this move. Okay, now we're into the algebra, and I think this is the easiest part, is now we can just get into the algebra, the step-by-step process of solving an equation, the algebra, okay? So here we have 2x plus x. This is going to give us 3x plus 30. I don't know if it probably bothers you guys that I changed colors. So let me stay with purple, and I'll go to the highlighting. So we have 3x plus 30 equals 180. What did I do there? All I did was combine like terms, so guess what we're going to do? We're going to write combine like terms. Okay, so this is combine like terms. We'll call this orange because we combined those ones right there. Okay, again, this is just algebra. This should be pretty easy. What do we do? Well, if we were just doing this problem like normal, we'd have 3x plus 3 equals 180. Our first step would be to try to get the x by itself. Subtract, oops, that's supposed to be 30, isn't it? Sorry, 30. And then change this guy to 30. Subtract 30 from both sides. Why can we subtract 30 from both sides? Again, let's go to our moves. These are, anytime it's of equality, essentially when we get to the algebra, a lot of these moves are going to be used once we get to the algebra. This one, this one, this one, this one. sometimes this one are going to be used once we get to the algebra, okay? So clearly if we subtract it from both sides, we're talking about the substitution property. So here we got to, what was our step? Once we subtract both sides by 30, we get 3x equals 150. How did we get here? We got here by the subtraction property of equality. Subtraction prop, that's abbreviation if you didn't figure that out, of equality. That's our move. That's how we justify it, okay? Last step, okay, what do we do once we get here? We divide by 3 to both sides, and we get x equals 50. So we're going to write the result here, x equals 50, okay? And then we're going to say how we got there. Well, we got there by using, how do we go from 5 to 6? We use the, oops, something's wrong with my pencil, division prop of equality, okay? And that's our final, this is when it's proved. You don't write prove ever, okay? Don't write proof or prove at the end. That's bad form. So that's how we did that. Now, this is probably overwhelming. It's like, oh my gosh, Mr. West, I don't know how we'd come up with all those statements. The reasons are tricky. This is a lot all at once. The important thing is being able to see, okay, we make statements, we make reasons. We'll build up with the rest with practice, okay? Here's one final example. I don't want to take up too much more of your time. We have angle 1 is equal to angle 3. Okay, so we have angle 1 equal to angle 3. And we're trying to prove that this guy, AEC, you can see my pencil's not really cooperating here, but we're going to power through it, is equal to DEB, those two angles, okay? I like to separate them. Anytime they're like this, I like to separate them, even though this isn't perfect, just to get an idea of what they look like on their own, okay? If we're trying to prove that these two angles are equal, I like to separate them. So I just kind of split them apart. You can see that I have part of this guy, angle 1. Angle 1 would be like right here. He's not all the way. It's like part of the way through this angle. And then angle 3, he's part of the way here. He's not all the way. Angle 3, okay. So we need to prove that. That's our goal, to prove that the pink and the green are equal to each other. Now let's start. Statement. Angle 1 is equal to angle 3. Well, look here. Given. Angle 1 is equal to angle 3. So we can write given here. That's easy. It told us in the problem. There has to be some given information, and that's what it gave us. This is the weird one. Measure of angle 2 is equal to measure of angle 2. Now, if you go up here, that's what we had for reflexive property. It's like looking in the mirror. I think you guys had A equals A, and I said in the part 1, it's like looking in the mirror. A looks in the mirror, sees himself, reflective, okay? A equals A. In this case, measure angle 2, measure angle 2. So this is reflexive property. Now, why do we even need to say that, though? Well, we need to say that because angle 2 belongs to both parts here. So angle 2 is here. Angle 2 belongs to this guy, this green angle, and it belongs to this guy, that green angle. See, he's in two different places. Because he's in two different places, we have to say those two angles are equal to each other. Okay. Otherwise, we might think, oh, this angle 2 is different than angle 2. No, they're the same. Even though they're in two different angles, they're the same, and that's why reflexive property is needed. It's kind of a really minor thing, but it's still important. Now, look here. We're adding angle 2 to both sides of this initial statement right here. So we knew 1 was equal to 3. Now we're adding 2 to both sides because it's equal. We're adding the same thing to both sides. That's the addition property. Okay, you can add the same thing to both sides of equality. Technically, this is of equality too. Of equality. Okay, so we can add something to both sides. Okay, now don't be too worried about, okay, how do we know we're supposed to add 2 to both sides? Don't worry about that part. The main thing is I want you guys to understand the reasons here. Now we have measure of angle 1 and angle 2. Okay, that's this guy right here. Angle 3 and angle 2. Okay, that's this guy, is equal to AEC and DEB. Now, 3 plus 2, that's this guy. This is the guy in pink. Okay, so really I should have changed this to pink. Can I go back and do that? Okay, so hold on a second. Check this out. This is going to be really cool. So here we have, I'm going to use the highlighter. Here we have angle 1 and 2 add together. Okay, and that's going to add up to this green angle. Dang it, I used a different color green. All right, you get the point. Okay, and that's AEC. Then we have the pink guy. This one I'm going to get right. 3 and 2 add together. Okay, 3 and 2. Notice how 3 and 2, they add up to give you DEB. Okay, this is a rule that we talked about in Chapter 1. If you haven't seen Chapter 1 yet, you'll see it eventually. But this is just some of the background information. This is the angle addition postulate. Basically, this just means if you have two smaller angles and they add up, it can create a bigger angle. Angle addition postulate. And like I said, the toughest part is kind of understanding a lot of these postulates, theorems, and having that background information so that you can make these moves in the proof. So now that we know these two guys can be added up to form the bigger angles, 1 and 2 forms the green one, AEC, 1 and 2, and then 2 and 3 add up to give you BED. Okay, now what we have here is we say, okay, well, I already know that these two are equal to each other. So now I'm going to say these two are equal to each other because they're equivalent. So I'm going to say, let me get my highlighter, this guy is equal to this guy. I've already kind of set it with angle 1 and angle 2 equal and 3 and 2 equal. So now I'm going to just label the names of those two angles, which is right here in our objective. That's our objective, to prove that. We don't write proof, okay? In this last one, what did we do? Well, we substituted the values. Substitution prop of equality. Okay, we substituted the values of this, and that's why we're able to do this. So we replaced this guy there, and we replaced this guy there. We substituted those values in, we got substitution property, and we finished this problem off. Hopefully this was a little bit enlightening about the intro to proofs, and I'll see you next time on Wes Explains Best. Thanks for watching.